Uh-oh. That should be fine. Where is the USB-C cable? Which is this one? I have the unicorn here.
That is me.
That's you.
Watching you there.
Here we go.
Unicorn. Kawaii?
Hmm?
Kawaii?
Mm-hmm. Kawaii, baby. I'd love to look at it there.
I don't know what to do.
With your shoulder? Did you look up what to do in general?
Huh?
Did you like look up what to do?
Today.
No, like have you asked like AI or something, what should I do for my shoulder?
No.
Oh. How's the coffee? Bad?
I didn't taste it.
Oh. Okay.
It would work, but that's obviously
Are we
not
gonna
efficient.
return this one?
For bigger one?
What we're going to do in this video is make this bit of code reusable. So going to our project navigator on the left side here, I'm going to right click and create a new group. And I'm going to call this utilities. And in the utilities folder, I'm going to...
Interesting. It's totally new. Oops. Didn't turn my key. Wait. Wrong side of my keyboard. My hair, it's so... I need cut, baby. Haircut.
put all the files basically for kind of the same thing as services, except services are going to be third party and utilities will be more internal stuff. And again, I'm just setting this up this way. When you make your own apps, you can change your files and your folders. There is no technically right or wrong way to do it.
Hmm?
I mean, tomorrow I'm going, so
Where are you going?
chiropractic.
Yeah.
Should I wait for tomorrow?
Instead of today, you mean?
Yeah.
Like going to the chiropractor today? Is he there?
I don't know.
Uh, do you want me to call them and ask if they're there today?
Do it. But the important thing here is just make sure that your code is always nice and neat and your files are organized.
Work like that?
Yeah.
Well, maybe I can call today and ask if they have Henry there.
Yeah. If it's not, that's fine.
Okay. Okay. Let's do some studying.
How you want to organize it, that's up to you.
My headphones are not connected. It's playing music. What? Where is it? Where's my... Oh, here we go.
But anyway, let's right click this utilities folder. Let's create a new file. It's going to be a Swift file, and let's call this networking manager. Go ahead and click create. This is going to be a class called networking manager. I'll open the brackets. And the first thing we're going to do in this networking manager is create a static func. I'm going to call this download.
Oh. Is it bugged in here? Did you see this?
Oh, yeah. Did you?
No.
Okay.
No. How can I do this? Oh, you want a new one here?
Yeah.
Okay, pull this.
Can you check function?
Check.
Yeah. Yeah.
There?
Mm.
Okay. Maybe you can take like a pain pill as well.
What,
If it
muscle?
hurts. Hmm?
For muscle?
Yeah.
It works?
Mm-hmm. Pain. In general, it works. Pain.
Can I not?
Mm-hmm. Hey. Gumi?
Everything.
Oh, it's not gumi.
But it's cool, right?
Hmm?
You want?
Oh, what is it?
It's no speaker.
Oh, it's just cool
Cosmo.
designs.
Yeah.
Yeah, I'll take that. You don't want it? You don't want one?
No.
I'm gonna put it on here. Take. Like my other one.
Is it two?
Yeah.
What's this?
Milk. I had extra milk when I was making like frothy in the machine, so that's why. All right.
Comfortable?
Yeah. Hey, enigmatic. Oh, you got a day off. Very cool. Visiting on me on your day off. Always trying to stay active on this. Although I just got Spider-Man 2 for PC, and oh, so good. I was up a bit late playing it last night.
And we're going to pass in a URL of type URL, and we'll open the brackets. And I'm creating a static func because this function is going to be the same function always. So if we created just a regular func, we would then need to initialize an instance of the class in order to access this download. But by creating a static func, we never need to actually initialize this class. We can just call networkingmanager.download. So I'm going to open up a second editor here, and on the right side I'm going to jump back into the Coindata service. Okay. So what we're going to do is basically take some of this code and put it into here.
Just want to set up a poll. Oh, here's a good one. Oh. Here we go.
Called networkingmanager.download. So I'm going to open up a second editor here, and on the right side I'm going to jump back into the Coindata service. Okay. So what we're going to do is basically take some of this code and put it into here. So I'm going to copy I'm going to copy from this receive on all the way through to this URL session here. I'm going to copy it, and I'm just going to paste it in here. And we want to return this whole publisher from this function. So we need to return a publisher, and I don't know what type of publisher this is. So for now, I'm just going to say let temp equals. And then if I hold the option button and click on this temp variable, we can see the type that this publisher is. So we can see that it is of type publishers.receiveOn, publishers try map, publishers.data dispatch queue. So I could copy this type here.
Huh. That's interesting.
I'm going to move this over quickly because we're not using it for a second. And we can just paste in this type as the return type, and we just need to import combine.
What the? Okay.
At the top here. And now our function is working, but we need to return it. So instead of saying let temp equals, we'll just return this URL session. So the error should go away, and now we are returning this whole type here. And now this obviously is a working function, but to any human, this is kind of ridiculous. Like, what type this is, I don't even know. Yeah. This is like some crazy publisher type thing. So one of the coolest things that we can do with Combine is actually call .erase to any publisher. And when we call erase to any publisher, it basically will take this publisher and convert it into an any publisher. So we get this error message here that I cannot convert any publisher data error to type, which is our received type. So I'm going to actually copy this any publisher and it just paste that here. So because we're erasing it to any publisher,
Okay.
we are then converting the publisher into this very convenient any publisher. So a little confusing, but basically this is just like a nice return type that we can get from this download function. All right, so now that we have this download, it's going to do all of this logic for us.
So this does. So this is the part that's connected here.
I'm going to jump into the coin data service. And instead of calling all of this, we're going to delete this. I'm going to call networking manager.download, and we're going to pass in the URL. So you can see how we're cleaning up some of the code from this function already, because now this networking.download we can use throughout our app. We can use this anytime we have any URL, we can just call .download.
You know what we should do here? We should do. How does this work again? Is it just this? I forget how to. Oh, we have to have the four. We're having a. Oh, you can't do this, okay. For here, I guess. Actually, I'm gonna check. Hello, Anshuman. We're doing networking stuff, apparently. We're creating our networks. Any job news? I'm checking if I can make this with a non-variable. A parameter name, sorry. That's what Then just for job, I found out pay is really shit. Oh. That kind of sucks. That's one of the #1 things you should ask as well. But it's fair you didn't ask because it's nerve-wracking, isn't it? Okay, yeah. There we go, that's what I wanted. I did ask, and gave me some ballpark figure after taxes it won't be enough for me to live on my own. Oh, that's annoying. What the hell? That's really stupid. What the? See if they have 2 jobs then. Unless, are you gonna use this job to backboard off and jump into another job, perhaps?
And it's going to do all of this logic for us. Let's make sure this still works. So if I open up the home view and I resume the canvas, if I stop it and play it again, if I reload this canvas and it still downloads the data, we do know it's still working. Awesome. I'm going to jump back into this coin subscription. And handling this sync completion here, this is pretty generic as well. So I also want to take this bit of code and make it a function in our networking manager. Okay. So here, if I were to call .sync, I could...
I think not. I'm pretty sure.
See that this returns us a subscribers.completion with an error here. So I'm going to actually just press enter and then copy this type.
Okay. Yeah, but the thing is, though, the starting pay is shit. In 2 years, I'd be well over 150K. Oh. Well? Is that worth it? To wait? 2 years, 150K. In 1 year, what is it? This is in Australian dollars, right? In 1 year, 77K. So, wait. 2 years skyrockets you exponentially? What the hell? Yeah, Melbourne. Okay. Finance. The performance bonus adds up. Oh. Okay. Well, I mean, maybe you could just try it and see how it goes, I guess. Do something else on the side, perhaps. I don't know. Like, base is 77, then another 34. Okay. I mean, it might be worth it. Like, yeah, it might be worth it. Just, you can, like, I don't know. I don't know how demanding the work is, but, like, you could maybe build your own apps on the side. And, Uber Eats. I'm telling you. Or YouTubing. That's my hope, right?
I could see that this returns us a subscribers.completion with an error here. So I'm going to actually just press enter.
Yeah, Australia is so fucked in terms of money for like, what the fuck? For living is so hard here. Yeah. You should really do that. You should really do that.
Here, if I were to call .sync, I could see
receive value. Receive completion, receive value. Wait, this is totally different.
See that this returns us a subscribers.completion with an error here. So I'm going to actually just press enter and then
This is definitely different. Hey, Luke. Good, how are you? We feel overwhelmed because someone in the US as a grad software engineer. There's a bug in here. It's paid 250k plus bonus. Well, I mean there are jobs that pay. Well, that is kind of crazy. But like there are jobs that pay more here, definitely, right? Like I'm sure you've seen other jobs with higher pays. I've seen a couple of those ones. Not 250k in US dollars though. I've never seen that much. That's insane. That is actually insane. That is almost 400k a year here. That's nuts.
copy this type. And I'm going to delete this sync code. Let's jump into our networking manager. Let's create another function. Let's say static func handle completion. And in here, we're going to pass in that completion. And we'll say completion of type, and it will be subscribers completion error. Then we'll open the bracket. And now in here, we just want to do that same logic. So I'm going to go back and I'm going to copy this switch statement. I'm going to paste it in here. So same thing, this
can we not yeah, I mean that amount is insane. I've never seen that much. Like that much. I've seen like 150k. I'm pretty sure I've seen a 200k job per year, but I've never seen 250. But I'm talking, Australian dollars, so nowhere near 250k US. Does bro for me remotely, even if they pay 35, I'd be more grateful. The international student, I'm already 200k AUD in debt. Yeah, you need a 200k a year job, get rid of all that debt in almost one go. A 300k, because you can't live off 200k if you're sending all the money to to the thing. Funk. Wait, how did he do this? Subscribers dot completion and just error? Okay, that's a type, I guess.
generic handle completion. And
how do you get the switch break? That one.
now that we have this generic function, we can reuse it a bunch of times in our app. So in our coin data service, I'm going to, instead of this sync, I'm going to call .sync. And where we have this first receive completion, I'm going to call networking manager let's Command Shift K to clean and rebuild. Let's call it networking manager.
What the?
家の掃除しようと思ったけど全然気分が乗らない。
Oh, there it is. Oh wait, what? No. Dot handle completion. Why is it doing that?
Dot handle completion, and I can actually just delete this completion input here completely. And then in our received value, I will click enter. So this will be returned coins. Let's make it weak self. Let's just copy and paste that code.
Weak self. Wait, what? Copy and paste what code?
Let's make it weak self. Let's just copy and paste that.
Oh, here. Right.
Code. And I'm going to get rid of our original sync.
Oh, perfect. I need at least 175k to pay off debt quickly and be able to plan on buying a house. How much are you expecting realistically for your first job? Dev job, John? Realistically, like somewhere in the ballpark of 70 to 90k, I would say. If below that, like if I had something for 50 to 60 but there was good prospects, I'd go for that too. It just depends on the you know, the place and the prospects and stuff like that. But I feel like like even if it's 50k, I wouldn't go lower than that. But even if it was, I feel like that's still a win because I've successfully gotten a job, you know. But yeah, obviously it'd be better if it was more.
I misspelled returned coins. And let's go back into the home view quick, make sure it is still working. Let's reload the home view.
Okay, it's working.
If we still see the data, we know it's still working, of course. And it is working. So now looking at our coin data service, we can see how much code we have saved from this file, right?
Yeah, not at all. And hoping and thinking positively, that's where the money's at. That's absolutely where the money's at.
Because the whole networking manager is now just this one line of code. And we did not include the decode in the networking manager because the decode is specific to this function, because this URL is returning us coin models. But if we go to another URL, it might return us some other type of model. So that's why we did not include this decode inside the download function. We just got this download function to go to the URL, return us data. So that once we know we have data,
Someone would pay me to overthink. Holy shit, me too. Please, we make millions.
We decode it, and then we can sync it. And we are syncing it. We are handling the completion generically in our networking manager.
Mm-hmm.
And then unique to this sync function is returning the actual coins. So, and I hope you guys are recognizing like why I'm going through all of this, because I know a lot of, especially beginner level courses, they don't walk you through these extra steps where you're like separating all your files and you're just creating these big massive files, but that's not actually very practical and realistic for like big production apps. If you ever start working on like very big apps and code bases, you're going to have so many files, and all of the files are going to have their own specific purpose, much like what we're doing here. Before we end this video, I'm going to jump into the networking manager and let's clean this up a little bit. Alright, so the first thing I want to do here is actually just update this try map, because we are doing it here, but if we wanted to create like a
Sydney swinging to his wedding so that his stepson wouldn't throw a tantrum for having his birthday party the same weekend as the wedding. Wait, what? Jeff Bezos invited Sydney Sweeney to his wedding so that his stepson wouldn't throw a tantrum for having his birthday party the same weekend as the wedding. Oh. Okay. But is she going is the question.
Second download that maybe use like a different publisher, we wouldn't want to repeat this bit of code as well. So what we're going to do is create a static func. We'll call it Arduino. I'm going to jump into the networking manager and let's clean this up a little bit. Alright, so the first thing I want to do here is actually just update this try map, because we are doing it here, but if we wanted to create like a second download that maybe use like a different publisher, we wouldn't want to repeat this bit of code as well.
Oh, she
so
was there.
What we're going to do is create
crap.
a static func.
Damn.
We'll call it handle URL response, open the parentheses, and the output here, if I hold the option button and click on the output, it is of type URL session.datatestpublisher.output. So I'm going to copy that, and we're going to pass out. We'll call it handle.
You're learning Combine? Nowadays. Well, I'm not. Well, yes and no. Like, Combine's involved in this tutorial, so I'm inevitably learning a little bit of it, but like, I prefer async await as well. I think async await is like actually much cleaner and nicer now compared to Combine. Combine seems like too cumbersome, especially if neither. I don't watch any sports. Maybe Messi, because he is a meme. He's memed. There's some funny memes about Messi. Yeah. I made my own, like, I believe it's async await here. Instead of, I think it's comparable to this, but the difference is, I think there's a difference here. I have to clarify again for myself, Taylor. I think there's a difference here where, like, we're dealing with subscription and publishing. So, I don't know if you know, but like, is that the same? Is that like possible through async await? Oh, we just got a new subscriber and the thing didn't notify. See, it is bugged, right? Because that was a public one. I got notified of that. So weird. Can't this system just get along with itself? What the hell? Well, we're technically at 9:34 again, because we lost one yesterday, I believe. Yeah, this thing, I don't know. This system's kind of bugged. It's not that, could be better. John, there's a faint music in the background. Make sure we don't get a copyright strike. Let me. I can solve this problem. I think. Mic mode. Can you hear me? Okay. Does it still sound okay? I'm on voice isolation mode. There's definitely no music in the background. Okay, cool. Thank you. Sweet. It's so annoying, this thing. Hello, Hadi. Hello.
URL response, open the parentheses. And the output here, if I hold the option button and click on the output, it is of type URL session.datataskpublisher.output. So I'm going to copy that, and we're going to pass.
Oh, there it is. Omega delayed. Why? Why is it so delayed? Thank you for your subscription, Magic. But why is it so delayed? Why? Then the goal wants to go crazy. Holy shit, X is popping off right now. Jesus, another one? Okay. I am working on a crypto app. Hi, Magic. Good, how are you? This is a crypto like app getting API data, web data from the what the hell? Can't move my from a CoinGecko, actually.
An output here of type the URL session.output. And this call and this try map, if we hold the option button and click on try map, we can see that it throws
Hold on.
the parentheses.
So we're
And the
looking at output here.
Here, if I hold the option button and click on the output.
Good, working on some stuff of my own. Awesome. Awesome. Glad to have you here while you're working. All right, boys, I'm gonna head out. Need to head to the gym. Good luck, man. Have a good session. You too. See you later.
It is of type URL session.datataskpublisher.output. So I'm going to copy that, and we're going to pass in output here of type the URL session.output. And this call and this try map, if we hold the option button and click on try map, we can see that it throws and it returns of type T. And the type that we are returning is data. So here our function, we want it to also throws and return data. Open the brackets. I'm going to copy this guard statement here and just paste it into here. And then instead of this try map up here, we're just going to delete this and call .try map. And in here, I'm going to open the brackets and call handle URL response. And the output is going to be $0. And then we're going to get a quick error message that this call can throw, so we just need to mark it with try. So same thing that we...
wait, this works, but okay. Interesting. What?
We're doing. So it's the same thing that we were doing, except
Thank you. Oh, good night. Thank you for coming in.
this code is now much cleaner.
Much cleaner code. Oh, we're at 935. For real this time. 935 subscribers. Oh my god. We're doing it. We're doing it. We're getting there.
Obviously, and this URL response is now reusable if we wanted to create a second download function. All right, and the last thing I want to do is set up custom errors, because this error is, is great, but when you're actually building production apps, you're going to want to build your own specific errors for specific things in your app. This way you can really manage and figure out exactly where things are going wrong.
Yeah, I much prefer that. That bug. Yes, I killed it. It's dead. So can async await work the same as sync? Oh shit, hold on. Sorry, my friend was calling me. Publishing feature. Streaming data. Observing with async sequence, maybe that's it. I wonder. Right, so async isn't as powerful as combine yet. More manual work. So it's more difficult. I mean, at the same time, I have to take this with a grain of salt because AI is really stupid sometimes. Best for live live data. That's not bad though. While test is not canceled. So combine's still worth it in certain situations like this. Definitely.
Something is crashing. So up here in this networking manager, let's create an enum and let's call it networking error. And let's make it conform to localized error and open the brackets. And I'm conforming to localized error because when we are printing out our error, we are printing out the localized description. So by conforming to localized error, we can give it customized localized descriptions. So we're going to have two errors that we're going to set up here. We're going to say case bad URL response and case unknown. And to customize the error message for each of these errors, we can just start typing error here and click enter. And we just need to give each of these an error description. So we will open the brackets. And then in here, so this is a variable that is inside of an enum. So basically we can switch on the current case of that enum. So we'll say switch on self. And this self is either going to be bad URL response or unknown. So we'll say dot bad URL response. And here let's make it a blank string for a second. And then we'll say case dot unknown. And we'll make it a blank string for a second. And we don't need our default case here. And we are actually getting some error messages here because we need to actually return the string. And return the string. And return the string. And in this bad URL response, let's set the error message to
Bebe, could I have some water? Arigato.
bad response
Thank you.
from URL. And for the unknown, we'll just say unknown error occurred. And let's actually add square brackets in here. And inside these square brackets, I'm going to press Control Command Space to open up the emoji keyboard. And if we get this, let's add maybe the flame. And then again in the unknown, I'm going to open and close square brackets. And in here, I'm going to add maybe the exclamation. I'm going to add maybe like the warning symbol. That might look cool. So I'm doing this just so that when it prints to the console, we can easily see, like with our eye, with the naked eye, that this is something that we had printed to the console personally. All right, so now that we have this error, we can just pass it in. So when we call handle URL response, instead of throwing this generic error from the system, let's instead throw a networking error dot bad URL response. All right, that should work. And then the last step here is I actually want to print out the URL response when we throw this. So in this return, I want to actually print out the URL that was bad. So on this case up here, I can actually add a parameter and it will be URL of type URL. So now our bad URL response is actually dot bad URL response with a URL. And here we will say let, and we'll call this variable URL as well. And now we can reference this URL in our string. So we'll backslash open close parentheses and we'll pass in the URL here. Let's make this a colon. So now we can actually print out this URL when we get this bad URL response, so we know exactly what the problem was.
Huh.
Finally, down here, we now need a reference to
So, URL type URL. URL of type URL. And then URL let URL. Okay. Right. So we put in the URL here. It takes the right or something.
the URL, right? So we can call it .bad URL response, but we don't have a URL. So in this function here, we will also pass in a URL of type URL. Pass that into our bad URL response, and then finally we need to update our handle URL response with the URL, and we'll pass in the URL from here down to here. So a lot.
Whoa. Okay.
Moving parts now, but if we get this error, we should get this printout. So before we end this video, let's just check that it is working. Because if it fails, we should print it out, right? Because we have the failure and then we're printing out the description. All right, and just to check that this printout is working, let's just force an error. So I'm just going to copy this throw and let's just paste it at the top here so that it always throws. So let's just run this and build this to a simulator quickly. And hopefully when our simulator loads, it throws an error and we can see it. So our URL response is going to automatically throw an error. So I ran it on the simulator and we threw an error. And we can immediately see our flame emoji coming into the console, which we have right here. It says bad URL response, and then we get the printout of our URL. So we know our networking error is now working. And let's just end this video by taking out this force error here. And let's build to the simulator one more time and just make sure with all these updates, we are still downloading the data correctly. Awesome.
You can just see it
The
here.
data is still pulling in and everything looks good. So again,
Perfect.
that was a lot of setup, but this is going to come in really useful as we start downloading more things from the internet, because we can just use these handy download and handle URL response functions without having to write this code again. So in the next video, we're going to actually start downloading some of these images. And when we do that, we're going to actually reuse some of this code. So you'll realize pretty quickly why we did this. All right. Thank you guys for watching. As always, I'm Nick. This is Swiftful Thinking, and I'll see you in the next video.
That one. That one was really heavy. Oh my god, another subscriber! Thank you so much, guys. Thank you. Oh geez, that was a heavy one. Um, I need a little break, actually. Jeez. Oh, man. This is definitely jumping ahead of what I know how to do. Jumping into a bunch of stuff that I did not know about. Sheesh. Um, right. So where's the next? I need to grab the next video. Downloading coin images using Combine, MVVM, and a networking layer. All right, I'm gonna shift gears here a little bit because I feel like I need to go over some basics. We're gonna swap over to some. We'll go through maybe his full file actually, his playlist here. I think this one is where I was in. I've done that basics. I've done this basics. I think we're in continue learning here. Yeah. Actually, let's go through. Ooh, sound effects is actually really important. I need that for my app. Um, you know what? Actually, I'm gonna get to hacking with Swift right now. Actually, I think I have my playlist here. Swift learning somewhere here. Yeah, how to handle errors. Is this it? In functions. Let's go with this one.
Things go wrong all the time. Whether it's trying to read a file and finding it doesn't exist, or trying to download some data from the internet only for the network to go down, or who knows what. Now, if we don't handle errors like these gracefully, our app will just go pop. It'll just crash.
I think I've watched this one
So
already.
Swift forces us to think about them,
Yo,
or at least acknowledge.
whoa. Hold on, another subscriber. Thank you guys. I'm gonna update that. It doesn't update right now because I don't know. This system's weird. But we have 937. Holy shit. We only need 63 subscribers, and we are a YouTube partner at that point. So maybe we can actually quit Uber. That'd be awesome. So awesome.
that they exist. This takes 3 steps. Step 1. Define all the errors that might happen in the code we're writing. Step 2. Write a function that works as normal but can throw one or more of those errors if a serious problem is found. Then, step 3. Try and run that function and handle any errors that come back. Now, I want to work through a complete example here. If the user asks us to check the strength of their password, we'll return how good it is. Okay, good, excellent, whatever. But if it's really bad, if it's too short or really obvious, we'll flag up a serious fatal error. Please fix it. So step 1, we want to define the kinds of problems that can occur inside our function. So we're going to say there's a new enum building on Swift's built-in error type. This has 2 cases, short and obvious. Password's too short or password's too obvious, those are 2 errors. And honestly, it doesn't define anything about what those 2 mean. They mean nothing. They just exist. There is a password error called short and a password error called obvious. Step 2 is to write a function that will trigger one or more of those errors. Now, when an error is triggered, or as we say in Swift, thrown, we're saying something fatal has gone wrong in the function. We cannot continue. Do not continue as normal. Don't try and send back a value. Just immediately terminate and throw up the error to be handled somewhere else. In our case, we're going to write a function that checks the strength of a password. It'll say, if it's really bad, fewer than 5 characters, for example, we'll throw an error immediately. If it's extremely well known, we'll throw the obvious error. But otherwise, return okay, good, or excellent ratings depending on how the user's strength is. Here's how it looks in Swift. First up, we'll say func checks password, password string, return string. But notice that throws keyword before the return type. We'll then say if we're less than 5 characters, it's too short. If it's 1, 2, 3, 4, 5, the same password I have in my luggage, though it's obvious. Otherwise, do various checks. Shorter than 8 characters, it's okay. Shorter than 10, it's good. Otherwise, it's excellent. Let's break that down to smaller bits. If a function is able to throw errors, we must mark it with throws. The throws keyword before the return type. We do not specify the kinds of errors that can be thrown. We don't say it throws a password error, just that it can throw errors. Now, being marked with throws means it can throw errors, not that it must throw errors. It could happen if things go wrong, but it might not. It might also work perfectly. In fact, we hope it does work perfectly, right? The happy path through this is it's all working great. When it comes time to throw errors, like in those first 2 lines of code, we say throw, followed by one of our errors. Password error.short or .obvious or whatever. This will immediately exit the function. It will not return a string. It will not run any further code. It will exit immediately to be handled somewhere else. Now, I've put the if password count less than 5 throw short all on one line, just for space reasons on my slide here, right? Ideally, you don't write code quite so compressed, but there's not a lot of space on one screen. If no errors are thrown, those first 2 lines pass nicely. We go to the next chunk and work as normal. It must return a string. We promise it will return a string. It needs to return a string. And that completes the second step of throwing errors. We've defined the errors that might happen, first step, then wrote a function using those errors, second step. The final step is to run the function and handle any errors that might occur. Now, Swift's playgrounds in Xcode are pretty lax about handling errors. They're mostly meant for learning. But when it comes to writing real Swift and SwiftUI projects, they will complain bitterly. They'll make sure you handle errors properly. And that means doing 3 smaller steps. First up, start a block of code that might throw errors by saying do and open brace. Then call one or more throwing functions by saying try. Then have a catch block to handle any errors that come back. Now in pseudocode, not real Swift, I haven't got this function yet, it looks like this. Do, try some risky work, catch, print, handle errors here. Of course, you want to have a some risky work function doing real work, but you get the idea. We say do all our throwing code, try this, try that, try something else, then catch the errors that come back. Let's try it out in Xcode with our real function. Here's our check password right now. I'll say let string equals 1, 2, 3, 4, 5. Then we'll do a do. We'll say let result equals try check password with that string. And then print password rating is result. Now I've got to catch the errors here. I'll just say print there was an error, like that. I'll press play, boom, there was an error, comes back correctly. Now what matters here is If the check password function runs successfully, it all works correctly, it'll return a value back into result and then carry on running the next line of code in the do block, which in this case will print it out. But if any errors are thrown, this whole do block ends. It'll jump straight to the catch block. Here, where it'll say there was an error. Now, there are a few different parts of this that really deserve more discussion, but I want to focus on the most important one, which is here, try. This must be written before all throwing functions as a signal to yourself and other developers that regular code execution might stop here. It might get to here and get no further because an error is thrown and it'll jump down to the catch block. Now, when you use try like this, you got to be inside a do block and handle the errors inside the catch blocks.
Ooh, Mac is catching up now. He has 17 votes overall, and Mac's like surpassed PC for development in our poll. I'm definitely in the Mac camp.
Some circumstances, a handful of circumstances, you can write a different version of try, which is try exclamation mark, which does not require do or catch. What it means is, I think this function is safe to throw with no errors. And if you're wrong, in this case I am wrong, you're risking a very fatal error here. This is what's an actual full-on crash here. So you've got to be really, really sure. And in practice, that's actually fairly rare. There are a handful of places I would do it personally, but nearly always I would not. I would make sure I use a regular try and do a do block like that instead and catch the errors carefully. So be careful around that. You want to know it exists, but broadly speaking, you don't want to do it. When it comes to catching errors, down here, you always have to have this catch block to handle every kind of error. Remember, we don't know what check password's going to throw. We can say it's a password error, but we're not saying that the way the function is defined. And so Swift will say it could be anything at all. Error, but we're not saying that the way the function is defined. And so Swift will say it could be anything at all. You can, if you want to, look for particular errors. So you can do custom messages. For example, I might say I want a dedicated catch block for password error .short. And this will do print, please use a longer password. Then we'll say catch password error .obvious. Print, I have the same combination on my luggage. And then this catch all at the end, sometimes comically called a Pokemon catch because you've got to catch them all, got to catch all errors. I'll press play now.
I'm sorry.
And it'll be run by, and it'll jump to this catch block. That's the one that was actually thrown, and it'll be put in here instead. As you progress, you're going to see how throwing functions are baked into so many of Apple's frameworks. So even though you might not make them yourself, having your own, throwing function like this, you at least need to know how to use them. It does matter. I would say most of Apple's own errors that get thrown do have a meaningful error message you could show to users if you wanted to provide some context, or at least put into a log file somewhere. Swift automatically makes this available to us in an error constant, and it's common to read that inside your prints or logs, whatever you want to. I could say print there was an error, and in particular, you want to look for .localized description, which is the description of what went wrong in plain language that the user can understand. It won't have one here because it's our own errors, obvious and short, but Apple's own ones will have meaningful localized descriptions you can work with. If I temporarily take out my other catch blocks, it'll run this last one automatically, and it'll print out the operation couldn't be completed. A generic error message, we haven't got a localized one ourselves.
So I think we're at the end of this one. Summary functions. So we got a summary here. Mac is popping off in the poll. I love these hacking with Swift tutorials.
We've covered lots about functions in the previous videos, so let's recap.
Everything feels so attainable when I watch
First up,
these.
functions let us reuse code again and again and again by carving them off from our main program and giving them.
You know when you just like, you do something and you're like, oh, I'm getting overwhelmed, and you need to go back to basics? That's kind of what's happening right now. Got a little bit overwhelmed with that tutorial, and now I'm just going through the basics here, which I haven't gone through all these videos actually, which is important that I do. Because I've gone like I've done a whole basics course, separate to this, and then I did, made apps and started working on stuff, and then I kind of went back and forth to these ones because every time I look at this guy's stuff, I always learn something new. We've been using his site. They have the text and code in the video, and also you can mark when you have seen it. Yeah, I have. But it was easier to like watch them through a playlist, the videos themselves on YouTube, which is why I'm watching him here. But yeah, I do use his site on occasion.
Name we can call. Second up, functions start with a keyword func, followed by the function's name. The function's body is placed inside opening and closing braces, much like conditions and loops. Third, functions can accept parameters to control their behavior. It could be 0, 1, 50 if you really want to. I wouldn't recommend it, but you can do as many as you need to. You list them out one by one with a colon and a type, then a comma, and the next one, and next one. You can, if you want to, add custom external parameter names if you need to make your code read more easily at the call site, or use underscore to disable the external parameter name for a particular parameter. Function parameters can have default values for common scenarios.
He is such a great teacher, yeah. He is. I specifically love him, and I love Nick from Swiftful Thinking, which is why those are the main videos I watch. I only occasionally watch Sean Allen. Sometimes Sean Allen is good with an explanation. It's like I'll watch these guys, for example, with a tutorial, and then I'll see a Sean Allen video about, that same thing. And so I'll just click on it because I already know about it, and then he'll like drive it home for me, if that makes sense.
And to use them. So if you're thinking, most of the time I want this same value, assign it a default value, and then forget about it. Don't specify it. So it just means just your function is a smart thing by default, but you still have the flexibility to override it if you need to. Functions can, if you want to, return a value, but to do multiple values being sent back, the best option is a tuple. This is similar to a dictionary or an array, but it has named values, and they're limited in size. They don't grow and grow and grow randomly. They're an exact size, exact types, and exact names. If you need to, functions can throw errors. Define enum.
So speaking of tuples, I want to check that out again. Why didn't he put the word tuples in here?
Uppercase, string, returns bool. Now, if you want to return 2 or more values from a function, you could use an array.
Yeah,
for example, we could write a function like...
Sorry, wait, what? Yeah, I used Sean a lot when I was a junior in Codeco. Was Ray Wenderlich when I started. Oh, interesting. I haven't heard of that one actually, I don't think. Yeah, tuples.
this
Wait, you don't know what tuples are?
one. Func get user returns array of string. Inside there will return Taylor and Swift. And we can then call that by saying get user and print out user 0 and user 1. This works, but it's problematic because it's hard to remember what 0 and 1 actually meant.
Mac, every time I say, as someone who has never used the Mac. Almost usable? Do you mean almost unusable?
And if we ever adjust it somehow, then 0 and 1 could be something else entirely, or perhaps not even exist at all. So it's not great. Alternatively, we can have a dictionary.
I feel like I don't know what it is about Mac, but it feels like I can actually focus using a Mac. If I'm on a PC, it's like there's a billion things that like I don't know how to explain it, but like there just feels like there's so much happening on a PC. I don't it doesn't make sense, I know, but like there's just this like intensity you could get, like this focus on a Mac in my opinion. No, it's improved a lot. Almost usable. Almost usable. Almost usable. Not quite, but almost.
We could say return a string dictionary. This time, first name is Taylor, last name is Swift. But this time, when we call it, we've got to say user first name and default question mark, and user last name default question mark. So we've got meaningful names to the keys inside our dictionary.
I don't need
but it's still messy. In fact, it's even worse in terms of code. It's pretty grim.
So I'm just
because we can't tell ahead of time if the values are there. Both of these solutions are honestly pretty bad, but Swift has a better solution in the form of tuples, or tuples,
Linux is great.
or tuples.
I haven't used Linux in, wow, years and years and years, but like, what, Mac is built on Linux, isn't it? Or something like that.
Like arrays, dictionaries, and sets, tuples let us put
Jonathan.
multiple values into a single variable or constant. But unlike those other options, tuples have a fixed size and can have a variety of data types really easily. And so we could rewrite getUser to use a tuple. We could say getUser returns a tuple, first name string, last name string. Then inside they return first name Taylor, last name Swift. And at the call site, we can now say name user first name and user last name. Let's break it down. Here is our return type. We're returning a tuple. That's the regular parentheses. We've got names, first name and last name, and they have two strings. Now, each string inside there has a specific name. It's not in quotes. It's not quote first name and quote last name. They are specific names of things inside our tuple, as opposed to the kinds of arbitrary keys we had in dictionaries. Then inside the function, we send back first name Taylor, last name Swift, matching what we promised. There'd be a first name string and last name string.
Oh my god,
then when we call getUser, we can read the tuple's values by using the key names, first name and last name. Hello. Now, I realize they will seem very, very similar to dictionaries, right? But they are different. Come on, you get a treat. Come on. Oops, sorry.
Oh, I remember this video is a lot about the dogs.
They are different. And they're different in various ways. You two, come on. Shut. Yeah, good dogs.
God,
First up, with dictionaries, Swift cannot know ahead of time if a dictionary's key is present. And so, yeah, we can look at it and say, user first name is totally there, it'll be fine. But Swift can't be sure, and that's why we have all those default values coming into play. When you read tuple values in comparison, Swift knows it'll be available, because a tuple says it's going to be available. That's the point of tuples. We then read values using user.firstname, not a string. So there's no chance of typos creeping in with types first name or first nam by accident. Can't happen, it won't work. These are values, not strings. And also, last one, you two, and also, our dictionary might contain hundreds of other values. We don't know. It's completely arbitrary how many values it contains. It could have the two we asked for and 500 other values. We just don't know. Don't take sister's treat. No, it's cheeky. No, cheeky. Come on, sister, go. Quick.
What did I do here? Let user one equal get user. Let user blank equal user one dot first name. It's one dot last name. This is a very weird way of writing this.
Okay.
Let first name.
Could have hundreds of other values. We just don't know. Could be lurking around all sorts of other things as opposed to a tuple, which is an exact size. So tuples have a really big advantage over dictionaries because we specify exactly which values will exist and what types they have. First name string, last name string, age, int, you name it. Whereas dictionaries may or may not contain the values we're asking for. Now there are three other differences, and it's important to know, to think about, when using tuples. And I want to walk you through them in code because it makes much more sense in code, I think.
I'm hoping we can get to 940 subscribers today. We need 3 more. Please. Basically, the let first name, last name, get user unwraps the response into new variables that you name. Let first name, last name equals get user unwraps the response into new variables. Oh. 2 separate variables, right? In one line. That's right. Thank you for that.
If you are returning a
Wait, we can do that because get user returns a tuple with 2 parts. Right. So would we be able to do that if we had like more? Would we be able to like return 4 things, for example? Also, Jonathan, it was you who was helping me figure everything out yesterday, wasn't it? With the decode thing?
tuple from a function, Swift already knows the names of the values inside the tuple. It's in your return type. So you don't have to repeat them when you call return. And so, we have here our tuple version, get user 3. We can actually just write Taylor and Swift. Those same tuple names are still being used because they're in our return type, first name and last name.
If the function returns tuple with 4 parts, you can unwrap it into 4 separate variables. Okay, yeah, cool. Exactly 4, otherwise it won't type check, right? Whoa. Oh yeah, okay.
So they can still be read down here. But we haven't got to re-specify them here because Swift knows the name must match the order we provided earlier. If you want to. Not required, you just can do it. Second, sometimes you'll find you're given tuples where the elements don't have names. And when this happens, you can actually read them using numerical indices like an array starting from 0. But it's not the same as an array because you know 0 will be there and 1 will be there and based on your tuple. For example, I could say this will return a simple string tuple. No names anymore, so we can't use first name down here. We've got to use 0. And down here we've got to use 1. And there's no worries about, oh, was there a value there or not? There must be a value here because we've said it'll have 2 values, 0 and 1, these 2 strings. So they're definitely going to be there. Now these numerical indices, 0 and 1, they're also available if you use tuples with named values, but I've always found preferring names is just better. Finally, if a function returns a tuple, you can actually pull the tuple out into individual values if you want to. To see what I mean, let's undo this code a little bit, get back to the named version. There we go. Boom. That's how it was originally here. We have down here, let user 3 equals get user 3, and print out first name and last name like this, both reading properties on user 3. It's a tuple, really. Instead of doing that, we can pull it apart into constants individually. We could have said...
But if you choose to assign the whole response to a variable, i.e. line 14, you can refer to that response separately. Like I did, right? Swift is annoying in that sense because there's so many ways to do things. That's true. There's tons of ways to do everything in Swift. Don't worry, you're not distracting me. I actually can't see the chat while I'm like looking at the video, so
let first name equals user3 dot first name, and
at the moment
first
at least
name let last name.
You know what I noticed? This guy, Paul, he like gets, I don't know, I get these vibes about people, and I noticed that, like, as subtle as it is, he hates mistakes. I can feel it. If he makes a mistake, he really gets upset. So like imagine like these are tiny typing errors and he's getting like it seems like he's getting slightly heated. Like more than you'd expect from a simple like typing mistake. And the other thing that indicates that to me is that he speaks perfectly almost all the time. He never has any like it's just exact. He has his sentence structure like already laid out in his head.
Equals user3 dot last name, and now just print out first name and last name, and that is the original sort of named version of our tuple. We can read first name and last name, copy them out from the tuple into individual constants before using them. We're just moving data around really here. That's fine, but there's a better version here. Rather than assigning these things to user3 and then pulling values out one by one, we can skip the first step. We can pull apart the return from get user3 directly into the two constants. We could say this: let parens first name, comma, last name equals get user3, and that will do exactly the same thing. This is called destructuring. We're pulling the function's returned tuple out into two individual constants. This syntax might hurt your head at first, but really it's just shorthand for what we had before. Convert the tuple of two elements into two separate constants. In fact, if you don't need one or more of the constants, you can actually go a step further by using underscore. For example, if you want to do just hello first name, we don't need last name anymore, so we can write let first name underscore equals get user3.
Okay. So let's do the checkpoint here. Now we have something we have to do. This is gonna be a harder checkpoint, I think, because it's a little bit more complicated stuff. Let's see.
With functions under your belt, it's time to pause, reflect, and try a coding challenge with checkpoint 4. Don't worry, again, it's not such a hard problem to solve, but I hope it makes you stop and think about what you've learned so far and try it out in real code. This time, your challenge is to write a function that accepts one integer parameter from 1 through 10,000 and sends back the integer square root of that number. Now that might sound relatively easy, but there are some catches. First up, you cannot use the built-in square root function or anything like it. You'll try and find the square root yourself. Second, if the number is less than 1 or greater than 10,000, I'd like you to throw out of bounds errors. I refuse to handle numbers like 10,001, for example.
Okay.
Third, only consider integer square roots. Don't worry about double stuff. Don't worry about the square root of 3 being 1.732, for example. Only think about 1, 2, 3, 4, 5, 50, and so forth. And finally, if you can't find the square root, I want you to throw a no root error. Now, for the avoidance of doubt, as a reminder, if you have number x, the square root of that number is another number such that this number multiplied by itself gives x. For example, the square root of 9 is 3, because 3 by 3 is 9. The square root of 25 is 5, because 5 times 5 is 25, and so forth. Now, I'm going to give you some hints in a moment, as always, but please stop now, try the challenge yourself, and see how you get on, because genuinely there is no learning without struggle. If it comes to you easy, it'll go away easily. Sometimes you learn stuff, forget it, learn it again, forget it again, learn it again, forget it a third time, but the fourth time you learn it and it sinks in and stays. And that's normal. That's part of the process of learning. In fact, it's a great thing. You find yourself forgetting stuff, don't worry about it, because you'll relearn it and it'll sink in deeper next time. Keep it in your mind, there is no learning without struggle. Okay, pause the video now, because next up are the hints.
All right. Before I fully start this, I'm just gonna grab a drink and get comfortable again, because I feel really thirsty. So, BRB. Or music's back.
What have you done? Now what should I do?
So maybe put those online then. You already took photos.
Just can I have my phone? Sorry. What time we going to Kmart to return stuff?
Yeah.
Where's today? Chicken today too.
Yep.
That's it.
I love that soup. Stuck. This chair is stuck. Okay. Right. Time to deal with this. So, I'm terrible with math. I mean, I used to be really good at math, but now I'm really bad. So, I'm gonna get AI to sort out the square root thing for me. Of a number in Swift, but several algorithms. He wants me to use an algorithm or what? Oh, you fell into me doing trying to do a checkpoint in the hacking with Swift. I gotta find a square root. Trying to find a square root of something without the square. But that's okay. I can't help me with math either. So we're the same. We both can't help each other with math. And neither of us can help me with it. Well, there's so many ways. Why does he want me to do that though? You can't use the built-in square root function or similar. You need to find the square root yourself. That's weird. Why does he want me to do this? First of all,
Okay.
let's get the hint for this part because I'm. Why would he? This is like complicated stuff here. Ancient algorithm. Or maybe he meant like this type of thing. Why is he making me do math? I think this is the one we need, except we. While I times I, variable I equals 1, well, I times I is less than or equal to number. If I times I equals number, return double I. Perfect square. Uh, let lower equals I minus 1. Let upper equals I. Let lower square. Let ratio equal double. I want the simple integer approach with just the perfect square option. Yeah, I like that one. So, right. Find the square root, which we are. You put your number in, and then it'll return a number. If it's. Wait. Text. Can we get this in here? Square root 10. Oops. Is that right? How do you get that in there? Why do I always forget to do how to do this? What? Oh, it was meant to be a otherwise a number. Otherwise -1? Okay. So we can get the square root now of return I if it's a square, if it's successfully square root. Otherwise return nil. Okay. Accept an integer from 1 to 10,000 and returns the integer square root of that number. I don't actually, how do I limit that? The number is less, oh, okay. Well, I times I is less than, the number is less than 1 or greater than 10,000, you should throw it out of bounds error. So Where do I mark try? Oh, I want to have it do try block, right? Wait. I think I'm overthinking this hard. I think I'm really overthinking this.
Stripe.
What the hell is this? Okay. Um so we want an error. So only consider integer square roots. Alright, I'm gonna take his hints because I'm lost.
If you're still here, that means you'd like some hints. Let's have a look. First up, this is absolutely a problem you should brute force. That means create a loop with multiplications inside. Are you the square root? No. Are you? No. Are you? No. Are you? No. Are you? No. Again and again and again.
So he's saying you need to do it like basically check, is this number the square root of... Okay, hold on. Let's see if we can actually do this. For I in 0. Do we need to return? For I in 0 to less than 10,000. If I times I equals num, turn true. I don't know. Print check. Wait, no. If it returns bool, I wanted it to print true. Uh, oh no, I don't want that. It doesn't work. Yay. What? Oh, can't do that. See, print throws me off so much. Stopped with the print. Wait. You know what? Let me just hear the hints.
This is absolutely a problem you should brute force. That means create a loop with multiplications inside. Are you the square root? No.
The function accepts an integer only. The integer cannot be less than 1 and more than 10,000.
This is absolutely a problem you should brute force. That means create a loop with multiplications inside. Are you the square root? No. Are you? No. Are you? No. Are you? No. Are you? No. Again, again, again. You can loop from 1 through 100 to cover all possible cases. Remember, the largest number I want you to handle is 10,000. And 100 times 100 is 10,000. So your loop can go from 1 through 100 to handle all possible cases. Third up, if you've got to the end of your loop, check all 1 through 100, and you found no match, that's when you throw your no root error. And if you want to, you can handle the number being too high, over 10,000, or too low, less than 1, with a single error. And if you want to, you can handle the number being too high, over 10,000, or too low, less than 1, with a single error. It's down to you. That's it. That's all the hints. Go ahead, solve the challenge, and have some fun.
I think the answer for this is actually not available unless you pay for his website. So we're using this thing here. So it's separate, right? It's going to be separate like this guy did. The do try is what was throwing me. Everything was throwing me. I knew roughly what I had to do, but so we need if num is less than 1 or greater than 10,000, throw error dot localize description. Does that work? No. Throw. Do we make error here? Okay, let me go back to the. Well, I times I is less than equal to number. Make sure num is greater than 1, else throw, here's a valid input, return error, right? Wait, no. We don't want to return an error. We want to return nothing, maybe? Or return an int. I'm assuming that gets the Uh, return. I guess it has to be that, right?
That's it.
Oh, wait. Now I'm kind of confused on what he actually means here. Throws in. Throw errors dot invalid. How did this guy do it? For a in 1 to 100, if a times a equals x, return a. Throw out of bounds dot no root. Do try print square root x9 catch out of bounds no root. Why import UI kit? When was this made? 3 years ago. Oh. We should do that too. For I in 100, if I times I equals number, returns So we don't want to use it. So we're doing a for loop then because we're dealing with the 100 is the if the number is 100, one greater than 1 or less than 1,000, it works. So you can choose a number within that range, and then what the heck? And then you can otherwise it creates an error. But within 100 times you're checking this. 100. If I times I equals num, return the number.
This.
Going back. Your shoulder.
Yeah. I'm not really tired. I can't see where is it, but
Up its turn.
it's really
Maybe just tell him that in the morning. Up it hurts particular.
Do you want now to eat?
Yeah. I'm hungry. I can eat now. One number error dot no root. Can you throw there? Instead? No, you can. Okay. Didn't know that. Right, so let's create another function. Do catch. And then return a string, just like the other one. And then we will, whoops. Do. Is that what it looks like? Yeah. Do. Let return result catch. How do we do the errors again? No. What the heck? Oh shit, you have a doctor's appointment today. Forgot about that. I forgot I had a doctor's appointment. Jesus. It's at 3:30. Holy moly. It's already 1:30 now. Check square root of 9 and return. Is there not a... How do I turn it into a string? I forget. It's like that? No. I forget how to do that. That should work. Doesn't work? That number equals 42. Try get string. We want to return it as so you can return result. That doesn't work? Okay. Right. Text do catch. Okay, that works. What if it, wait. No, we return. Hold on. No, no, no. That's not what I want to do. I want to. And then can I call do catch in here? Oh yeah, cut off the throw will not be executed. Will it go here? No. Do catch goes into Uh, Holy, I don't know what I'm doing here. Does that work? It does work. Error. We want it to return. Return switch on error. No. Right now it's only returning error. This returns no string. Import Cocoa. Get square root of a number. Throws int. If number is less than throw number error amount for this. Try no. Throw number errors no root. Get no root error. Let try let result equal try. Return result. Maybe I won't do a return here. What the? Still needs a default. What the? That's what I did. Ryan 1 to num. See, this is a confusing, unclear one. Just gonna go back to here and then call it a day.
Things go wrong all the time. Whether it's trying to read a file and finding it doesn't exist, or trying to download some data from the internet only for the network to go down, or who knows what. Now, if we don't handle errors like these gracefully, our app will just go pop. It'll just crash. So Swift forces us to think about them, or at least acknowledge that they exist. This takes 3 steps. Step 1. Define all the errors that might happen in the code we're writing. Step 2. Write a function that works as normal, but
Sorry, my love.
throw one or more of those
I have to go doctor in 1 hour, pretty much. 2 hours, I mean. I forgot about doctor. You want to come with me? And we'll just go shopping? We'll just go after. Or I can just go and do the mat.
errors if a serious problem is found. Then step 3, try and run that function and handle any errors that come back. Now I want to work through a complete example here. If the user asks us to check the strength of their password, we'll return how good it is. Okay, good, excellent, whatever. Our function. So we're going to say the new enum building on Swift's built-in error type. This has 2 cases, short and obvious. Password's too short or password's too obvious, those are 2 errors. And honestly, it doesn't define anything about what those 2 mean. They mean nothing. They just exist. There is a password error called short and a password error called obvious. Step 2 is to write a function that will trigger one or more of those errors. Now, when an error is triggered, or as we say in Swift, thrown, we're saying something fatal has gone wrong in the function. We cannot continue. Do not continue as normal. Don't try and send back a value. Just immediately terminate and throw up the error to be handled somewhere else. In our case, we're going to write a function that checks the strength of the password. It'll say, if it's really bad, fewer than 5 characters, for example, we'll throw an error immediately. If it's extremely well known, we'll throw the obvious error. But otherwise, return okay, good, or excellent ratings depending.
Hmm? No, not yet, because I'm waiting for the sale, remember? No, not yet. Didn't order yet.
On how the user's strength is. Here's how it looks in Swift. First up, we'll say func password, password string, return string, but notice that throws keyword before the return type. We'll then say if we're less than 5 characters, it's too short. If it's 1, 2, 3, 4, 5, the same password I have in my luggage, so it's obvious. Otherwise, do various checks. Shorter than 8 characters is okay, shorter than 10 it's good, otherwise it's excellent. Let's break that down to smaller bits. If a function is able to throw errors, we must mark it with throws. The throws keyword before the return type. We do not specify the kinds of errors that can be thrown. We don't say it throws a password error, just that it can throw errors. Now, being marked with throws means it can throw errors, not that it must throw errors. It could happen if things go wrong, but it might not. It might also work perfectly. In fact, we hope it does work perfectly, right? The happy path through this is it's all working great. When it comes time to throw errors, like in those first 2 lines of code, we say throw, followed by one of our errors. Password error.short or the obvious or whatever. This will immediately exit the function. It will not return a string. It'll not run any further code. It'll exit immediately to be handled somewhere else. Now I've put the if password count less than 5 throw short all on one line, just for space reasons on my slide here, right? Ideally, you don't write code quite so compressed, but there's not a lot of space on one screen. If no errors are thrown, those first 2 lines pass nicely. We go to the next chunk and work as normal. It must return a string. We promised it will return a string. It needs to return a string. And that completes a second step of throwing errors. We've defined the errors that might happen, first step, then wrote a function using those errors, second step. Now, the final step is to run the function and handle any errors that might occur. Now, Swift's playgrounds in Xcode are pretty lax about handling errors. They're mostly meant for learning, but when it comes to writing real Swift and SwiftUI projects, they will complain bitterly. They'll make sure you handle errors or more throwing. Of course, you want to have a some risky work function doing real function. Here's our check password right now. I'll say let string equals 1, 2, 3, 4, 5. Then we'll do a do. We'll say let result equals try check password with that string. And then print password rating is result. Now I've got to catch the errors here. I'll just say print there was an error, like that. I'll press play, boom, there was an error, comes back correctly. Now what matters here is if the check password function runs successfully, it all works correctly, it'll return a value back into result and then carry on running the next line of code in the do block, which in this case will print it out. But if any errors are thrown, this whole do block ends. It'll jump straight to the catch block. Here, where it'll say there was an error. Now, there are a few different parts of this that really deserve more discussion, but I want to focus on the most important one, which is here, try. This must be written before all throwing functions as a signal to yourself and other developers that regular code execution might stop here. It might get to here and get no further because an error is thrown and it'll jump, crash here. So you've got to be really, really sure. The catching errors down here, you always have to have this catch block to handle every kind of error. Dot short. And this will do print, please use a longer password. Then we'll say catch password error. Look for particular errors. So you can do custom messages. For example, I might say I want a dedicated catch block for password error dot short. And this will do print, please use a longer password.
Oh, now I see how catch works with the enum. Right. Okay, I was getting confused about that. All right, I have to go do some stuff before I go to the doctor, so that's gonna be it for me today. Thanks everyone who came in to chat. Thank you for the last minute subscriber, 938. That's awesome. Thank you so much. We're almost there to be able to quit Uber. So excited. And I'm gonna keep looking at jobs. Hopefully there's something I can apply to. Alright. Catch you guys on my next one. Gotta head off. See ya.